Today we're going to move on to the geometric transformation called reflection. Remember the FL in reflection? That would remind you that the FL here means there's a flipping of the pre-image. Flip. Look at my hands. Flipping. All right? So remember that. So at this first part of the lesson, I want us to focus on the movement and the changes that will happen. Okay, what changes in size and shape of the following. Okay. So let's reflect first along the x-axis. The x-axis we all know is the horizontal line. Check out the red mark here. That's the horizontal line. So that means this pre-image will be flipping along that line. Imagine that that is a mirror. What will be the image on the other side? So it's going to be like that. Do you agree? Right. There's a flipping, and this is what happened. Let's have another one from the bottom. And again, our uh, axis of reflection will be the x-axis or the horizontal line. Therefore, this line will be transported on the other side. But how will it look like? We're not sliding, we're flipping. Okay, so if the bottom part of the L here will now be the top part over there. So that's what the characteristics of flipping. Remember that. Now we're going to do a reflection along the y-axis. What is the y-axis? Y-axis is the vertical line. Vertical line. When you say vertical, right? Imagine that's the arrowhead. See, it goes down or it goes up. Okay, so this letter L will be transported on the other side. How will it look like? Check it out. See? And also I want you to discover the distance from the line of reflection. 3 units here, 3 units there. But we're going to do that later. We're just after the characteristics of the image. How about here? So this will obviously be on the other side. See, take note, the distance is also important. I cannot just simply put the drawing here because that's not a perfect reflection. Even the distance should be consistent. Take note of that. So, from those reflections, what can you say about the following? The size, did the size change? No, it's the same. How about the shape? Is it still a letter L or did it morph into another figure? It is the same, correct. The location, obviously, okay, is not the same. And the orientation, is there a flipping? Obviously, that's why the orientation is now different. Corresponding angle, did the 90-degree angle, when flipped, is it still 90 degrees? Oh yes, it's preserved. How about the sides? If the side is 10 inches, if you flip it, will it still be 10 inches? Yes, it's preserved. And how about parallel lines? If you flip your parallel lines, are they not parallel anymore? They're still parallel. There you go. So remember these characteristics of translation. Now we will focus on the coordinate points and we will take note of the changes that happens in the x and y axis. All right, so there are a lot of vertices here, but we just focus on one point, letter A. Okay, if you name A, that's going to be 5, comma 2. Obviously, we know how to name the coordinate point. Okay, so we will reflect along the x-axis. That's your x-axis. So where will the figure be in quadrant 1? Remember this quadrant 1, 2, 3, or 4. Write in the chat. Where will the new figure be? In which quadrant? Write it below. All right, correct. It will be in quadrant 4. So let's check if we're right. So the flipped image will look like this. Okay, do you agree? That's the flipped image. All right, but take note of letter A. A before was 5, 2. Now it's going to be, it preserved the 5. Obviously, it's still 5, but it went down, therefore 5, negative 2. 5, negative 2. Again, take note, the distance from the mirror is 2 units. Therefore, on the other side, the distance from the mirror or from the line of reflection is also 2 units. It cannot be shorter, it cannot be farther. Let's try another reflection on the x-axis. Will this be in quadrant 1, 2, 3, or simply stay on 4? Correct. It's going to be in quadrant 1, and this will be our new figure. Check it out. B prime, oh, there should be a prime symbol here. So B prime would be how many units? 1, 2, 3, 4 units here. Obviously, on the other side is also 4 units. Be sure you preserve that too. Okay? So take note of the coordinates. What happened to 2, -4? It became a 2, 4. Oh, are you thinking of a pattern already? Okay, before you generalize on that pattern, let's now do uh, a summary. So these are our reflections when we reflected along the x-axis. Remember, our focus was just the x-axis. So what can you say about the pre-image and the image? Write down in the chat what's your observation in the comments. Okay, correct. What have you observed? Number 1, we retained the 5. Whatever was the x was retained. Correct. What happened to the y coordinate? The y coordinate, 2 becomes a -2. Yes. What do you call that? When a 2 becomes the opposite of, yes, the opposite. There you go. So let's see. If we started from 2, -4, same again, we retained the x-axis and the y coordinate. What happened? The -4 became a +4. So it's the opposite. All right. Another name for opposite is the negative of another number. The negative sign of the other number. So a negative of a positive is a negative. And a negative of a negative will be positive. See that? Now, thus, these are all reflection along the x-axis. Along the x-axis, the horizontal line. Let's now move to the reflection along the y-axis. Check it out. That's the y-axis. Okay, now, from here, we are at 4, 5. That's point C. Our focus is point C now. Okay, so if I reflect along the y-axis, it will be in which quadrant? This quadrant, and that's quadrant 2. All right, let's see. This is quadrant 1. You remember that. So on the opposite side, if you flip this one, it will look like this. Check again. Distance correct. 3 units away. The other side is also 3 units away. There's the flipping. All right. But what is the new coordinate now? It's not 4, 5 anymore. It's -4, comma 5. Write it down. We will make an observation in the next few slides. Let's have another reflection. All right, we start now from quadrant 1. This is 1, 2. We now start in quadrant 3. Where will the reflection be if we reflect along the y-axis? All right, so try it. Yes, definitely it's going to be in quadrant 4. But where will it be? Everybody look. So, there you go. Now, what is the new coordinate? The new coordinate is 6, comma, -5. What have you observed? Oh, let's check again the distance. How far away is, let's try -6. -6 is how far away? 1, 2, 3, 4, 5, 6. Obviously 6 units. And then on the other side is also 6 units. Okay, every corresponding vertex should be equidistant with the line of reflection. Okay, take note of that. All right. Let's now summarize our data. So this one, we're done with this. We're done with x-axis. We made our observations. Our focus now is reflection on the y-axis. Okay, so what have you observed here? 4 became a -4. Oh my goodness. So the -4, I mean the +4 became a -4. And what have you observed about the y-axis? The y is retained. It's still a +5. How about the next one? So same thing. -6 becomes a +6. That's the opposite. Okay. And what happened to the y-axis? The y-axis was retained, same number. Okay, make a rule now. Think of a rule so we generalize everything. All right, so when we reflect along the x-axis, we remember that we retain the x. X is the same. Think of that. X-axis, x is the same. So the other one is the opposite. Okay, how about if you reflect on the y-axis? The y-axis, obviously, the y is the same. You retain the y, and then the x is just the opposite. All right, think of the opposite as the negative becomes a positive and a positive becomes a negative. So that's the rule. Remember? Okay, now let's try. Pause, solve, and play. Okay, let's start with this. This is how you analyze. I'll just give one example. You reflect along the x-axis. Ooh. If you reflect along the x-axis, the x remains to be the same. So I will put a negative 2, same, but negative 3 will be its negative. What is a negative of a negative? Okay, the negative of the negative negates it, so it's going to be a positive. And you could say the opposite of negative is positive. There you go. All right. Now, try the next one. So let's see if you're right. Pause. Answers. B comma negative 5 because you retain the x. Retain the x. Opposite of 5. There you go. How about the next one? Oh, reflect along the y-axis, so preserve the y. Preserve the y. Okay, so therefore you could say the opposite of negative 5, the negative of a negative 5 is a positive 5. So 5 comma 7. And how about the next one? Retain the negative 9, and you will be your opposite, negative what is the opposite of negative 8? It's going to be positive 8. So positive 8 comma negative 9. Are we good? Now let's try this challenge on your own. Okay, try the following. Pause and then I'll show you the answer. All right, the answers. Here we go. Reflect along the x. So the x is preserved. Preserve that. 9 comma positive 2. Again, along the x, preserve the x. B prime will be negative 3. Change the other one to the its opposite, negative 7. Correct. How about this? Reflect along the y. I will preserve my y. So you're the opposite. So the answer is 4 comma negative 6. That's C prime. And D prime, oh, this is a challenge. Let's see, what did you do? I retain my y, so you're still a negative 8. But what's the opposite of 0? Oh, the answer is 0 comma negative 8. It's still the same coordinate. No change. It stays there. All right. So again, let's summarize. Okay, now let's summarize. If we reflect along the x-axis, x meaning preserve the x. Okay, only the y change to its opposite. Good job. So retain the x, y becomes a negative y or simply the opposite. So we reflect now along the y-axis, which is preserved. Yes, the y is preserved. Only the x becomes its opposite. So again, retain the y value, and then the x becomes its opposite, its negative value. Okay, got it? Good job, people.